Okay, this is the week 5, lab 5 activity in the morning section, June 7, and you are asked to solve this problem, which is from a previous midterm, by the way. So we have an object like that, and it is on a massive planet, and therefore the gravitational acceleration, which is in this direction, is given as almost 10 g, 10 times the acceleration, 10 times the g on Earth. So 3,860 inch per second square. On Earth, g is 9.8 meter per second square, or 32.2 feet per second square, or 386, roughly 386 inch per second square. So we are told that wherever this is being conducted, the gravitational acceleration is 10 times g, which is that number, big planet. Now, when you look at this, although you may get the impression that, oh, I can go and model everything in CATIA with solid element and then go and measure it, etc. Yeah, but we have been discussing this thing for the past 2 days, and that is when you look at that, you should realize that this block in the middle, this cylinder in the middle, should be done with solid element or tetrahedral element. This plate should be done with shell element, and these ends should be done with beam elements. We are assuming that perfectly, everything is perfectly welded together and things of that type. Okay. So anyway, you have two choices. You can do this thing as a single part. This is what we call a hybrid problem. You can do it as a single part, or you can do it as an assembly of parts. Okay. Now, the other thing is that you are told that these ends are clamped, and uh, use the most appropriate elements, and I already described that to you. The middle one is solid, the plate is shell, and these ends are beam. However, use symmetry as much as possible if applicable. Now you can see that based on what you have here and the loading and everything, all you need to do is half of this. In other words, you make a cut vertically on this side, okay, and then you do either left or right. The choice is yours whether you make the entire object and then cut it using splits and whatever the split or the saw, or you can actually make half of it uh, to begin with. And that's what I'm going to do. I'm going to make half of this model and then proceed. Okay? So let's go ahead here. Let me make the cylinder first in the middle, or half of the cylinder in the middle. We start with the part file because we decided that everything is going to be done in a single part. Okay, so for example, on that horizontal plane, I will sketch. Well, I'm trying to draw the circle, or the cylinder in the middle, half a cylinder in the middle. So I'm going to draw a half a circle, and then close it like that, and then close it with a line like that, because later on I'm going to pad it. Okay, let's put the right dimensions here. I think this radius is 1 inch. All right, exit. And then you want to pad it. Obviously, we are in wireframe and surface design, so we can't pad. We have to switch to part design. And then we have a pad here. We pad it up by 2 inches. That's what the height of this thing is. It's this. Let me close that. Yeah, it's the height is 2 inches. Oh, the radius. Yeah, the radius was 1. That's fine. Now, the next thing we're going to do is to create that plate at the bottom of this. Okay, so there are different ways of doing this problem. The way I'm going to do that is following. You go ahead and make your part any way you want, as long as it looks like what I have and you can run it. That's fine. So on that horizontal plane, I will sketch. Here's what I'm going to do. I'm going to project this circle, or half a circle right there, and then do the rest of it. What do you mean by the rest of it? I mean, basically create this profile here, and you have to put, of course, dimensions, and we're going to do that in a minute. Okay, so let's clean it up. Left control, right control the middle axis. You make it a symmetry, and then this is 4 inches. Sorry, 8 inches. This length is 8 inches. Look at your drawing. You see that? 8 inches. And this height is 2 inches. So this is 2 inches. And exit. Now notice that, let me hide this for you. Because of the way I did it, this is a single closed curve in a plane, in the sketch plane, and I can put a surface on it. As soon as I say surface, obviously you have to be in uh, either generative shape design or wireframe and surface design. There we are. That's what we have been doing for the past 2 weeks. And then there is an FILL, fill. See that? Fill, where you make surfaces. Fill, FILL. You select that, you put a surface through it, and there we are. Now the other guy is in hiding, of course. I can bring it here, and this is what we've got. Incidentally, what I could have done was could have created a surface here. I could have created a surface here, rectangular surface, and created the path later, and then make a connection, fasten connection between the bottom of this uh, sphere, cylinder, and the surface. Would have been equally acceptable. I'm doing it differently. Okay. Now, and the results are not identical, but they're both acceptable. Okay. Now, the next thing I want to do is to create these lines here, these lines. So one way to do that is to say, okay, I'm going to create a line, and the line is a point and direction. So for the point, I select this point. The direction is direction X, and 1 inch to the right. So I'll put a -1 here, and it should go on the other side. -1, preview, yep, that's good. And I'll repeat it on this side, except that I go +1. So another line, point and direction, this is the point. Direction is again X, and the value is +1 this time. So the line is going to go like that, okay? Now, because I'm doing these things as wireframe, I'm not doing it in sketches, there's no reason to join them. If you can still mesh it and do the problem. But if these were actually sketches in certain planes, then you would have to join it, but I don't need that. Okay, everything is made out of steel, we're told. So why don't we go ahead and apply material here. Everything is made out of steel on that part. We say okay. And I'm going to save everything. So file, save management, save as, one level up, new folder. So activity 5, week 5, morning. All right. We're done here. So now we're going to go to generative structure analysis. We say okay. Let me change the rendering here. Yeah. Let me change the rendering. Now, notice that the cylinder is already meshed because CATIA sees a solid object, immediately it meshes it, which is fine. Now I have to do the meshing of that surface, so I use the triangle mesh here. Select that. This is too big, so I'll make it maybe 0.2. Let's see how it looks like now. Yeah, it's more reasonable. And the thickness of that plate is, I believe, we were told that the thickness is 0.1. Okay, so 2D property, select that guy. 0.1 is already there because we did it in the previous problem. All right, and now I have to mesh the beam. I can mesh with this thing. This is 1 inch long, so it puts two elements because the size is 0.5. I'll make this thing 0.1. Okay, so 10 elements this way, and incidentally, 10 elements that way. Okay, so this is also 10 elements. Good. Now I have to put a 1D property on that. 1D property for this. It is circular, cylindrical, and we are told, if you read the problem carefully, we are told that the cross section is a circle of radius 0.02, right there, 0.02. Okay, so I click on the range, put a 0.02 there. That takes care of the one on the right. Okay, and I have to do the same thing on this side. Let me just make sure that it is there. You can see that it's so small that from a distance you can't see it, but it's right there. Okay, and the same thing on this side. Uh, same information right there, and then say OK. And here, even here, you can see that it's right there. Okay, good. So let's save the analysis. So file, save management, the analysis, save as. Yeah, activity week 5 morning. That's good. It's in the right spot. And now we're going to do the restraints. So first of all, you're told this end is clamped, the other end is clamped. So let me clamp that end. Good. And clamp this end. Okay. And you can see if you zoom in, you see the clamp sign there. But there you can see that. Yeah. Okay. Now we use symmetry here, surface slider there. So surface slider on that face. And these, if I hide the sketch, let me hide the sketch here. These edges lie in the x-set plane of symmetry. So user defined, uncheck everything, lies in the x-set plane of symmetry. So no translation in y, and rotations opposite. So it's that guy and this guy. And say OK. Very good. And now if we the load is G, acceleration. Here is the load toolbar right there, and this is the acceleration due to gravity, and it is in the direction. First of all, you select the whole part, okay, but the direction is direction X, 3,000, direction X, 3,000. 860 inch per second squared, massive planet, huge acceleration, and it goes like that. Now this also that's applied to. Let me see if I need to apply it to this. So acceleration on that, yep, because it looks like you have to do it all the involved parts, not parts, but involved type of elements. So do another one for the beam. The beam may not display it though on this guy. Let me see for a second. Yeah, the beam doesn't display the acceleration, but yeah. Okay, good. So everything is taken into account. Now, uh, if I run it, it's going to bomb out. You know that. Let's actually go ahead and do that. So we save this thing. We're going to run it. And it's going to bomb out because this whole thing can move as a rigid body. These guys don't know the other pieces are present. And you can actually check it out. Here's the deflection, and you can see that it goes through it like knife through butter. can see that. You can see that, yeah? Okay, so what we need to do is the following. Deactivate this plot, deactivate that plot, we create connections. And there are different ways of doing it. One way is a connection between this face and for the second component, that edge, okay, that edge. And we say, okay, and this is going to be fast. And I'm assuming that this is perfectly welded to that sheet, okay? So this connection that we created right here, I can make it fastened right now, right there. Face-face connection, fasten. Click, there. So notice put the fastener sign there. Now, if we run it, it's still going to bomb out because these two are not kind of connected to each other. So let me do another analysis connection between the end of this pin. Let me hide this, the end of this pin. And for the second component, that corner, so the corner, I'm going to bring this in the front. I'm going to hide the beam, the line, and I can't pick that corner because this white rectangle is sitting here. That uh, icon for connection, I'm going to hide that, and now I can select this corner. And let me remind you that when you do point to point, you cannot use fasten, you have to use rigid. So rigid connection in distance connection property, here is the rigid, and you select the one that you just created, and all degrees of freedom are transmitted, so that's okay. And I have to repeat the same thing on this side, okay? I have to repeat the same thing on this side. You click on that connection, hide the fellow, select this end, go to the second component, bring this thing to the show mode, hide the line, and hide this dot. This dot, white dot, is basically the connection, which is blocking me from selecting that point right there. And then we say, okay, here is the other connection that I created. You see that? That's this one. This was the one on the left side. This is the one on the right side. And we're going to make it rigid. Select that. And we say, okay. And lo and behold, everything is done. I mean, these lines, by the way, I hit them. If you want, you can get it back, but it's not going to do anything particular. It's there. You can see that. Now, save the analysis and run it. So, run it. Okay. So, when this kind of a thing happens, I do have a suggestion. Try to fix your connection this fasten connection property. So I say, okay, let's see what happened there. You see that this guy seems to have a problem. I'll do it an alternative way. Let me go ahead and delete this. Let me go ahead and delete this fasten property because that has a problem. You don't have to delete it, but here's what I can do. I can say, okay, I'm going to double click on this. Well, actually, you can't double click it from here. You go and double click on you go to property. Sorry. You go to, let me see. Okay. First of all, let me delete this warning. All right. So obviously this has a problem, right? So, and double clicking on this fasten is not going to get you anywhere, but double clicking on this connection is the connection that's causing the problem. Right here, connection, right there. Double click on it. Let's try a couple of things. Instead of doing face to edge, okay, let me do face to face. In other words, the face of the cylinder and the face meaning that surface. So I'm going to remove the support edge, and instead of the edge, I select the entire face. Okay, so face of the cylinder and the surface that I created. And I say, okay, all right, and now let's try to run it. Good. So depending on how things are, certain choices that you make may have to be modified. Like here, first I did the face to edge, it bombed out for me. Okay, you could have tried first edge and then the face of the cylinder, see whether it's working or not. But I decided to bypass that and just say the face of the cylinder is basically fastened to the face of that plate. Okay, so let's see now. This must bend to the left. So if you look at the deformation, gravity pointing this way, so it must bend to the left. Let's check it out. Reset the scale. There. If the gravity is pointing that way, it'll make this thing bend this way. And of course, you can do the rest of the problem. For example, you can look at the von Mises stress. The only thing is that you cannot do von Mises stress in the beams. Okay. And some of the stuff that is blocking your view, you can hide. For example, you can hide all these connections. See now, hide these. Hide these elements. Hide the mesh. Okay. Hide the properties. All right. Hide the restraint. What's the restraint is right here. Hide it. Hide the load. Where is that? Hide. Okay. And then if you want, let's look at the deflection instead of von Mises stress, because von Mises stress doesn't show you the things for the beam. So deflection. Let me change this into average ISO. There we are, and you can see the beam. The beam actually shows the deflection of the beam. So you can animate it if you want. Gravity makes it point to the left. Okay, and then we say okay. So that takes care of this activity. What happened, just to refresh your memory, what happened is that when I selected the face of the cylinder and the edge of that sheet, it didn't work. It gave me an error message, etc. It didn't work. So what I decided to do instead is select the face of that cylinder and the face, which means the surface that I created, and I made them fasten. Okay. There are some different, even if the first one ran, there will be some differences between even if first case ran between the first run and the one that I just did. However, if the mesh is small enough, if the mesh is reasonable, these differences are also small. All right, folks. So good luck. By the way, if you did it and it didn't bomb out for you, this last run, the second last run that I made, and it didn't finish, then and you may want to, it may not happen to you for certain reasons. Okay, the reasons and how you generated the geometry may be different from mine. Your mesh may be different from mine, etc. So yeah, it's not that we should be getting identical results. And good luck.